afternoon from Europe. Good morning to the Americas. Good afternoon to Middle East and Central Asia, and good evening to the Far East and Australasia. Wherever you are in the world, welcome to today's PETinar, which is the first of 2023. Now, we have something approaching 200 people who have registered to join us today from dozens of countries across the globe, and thank you all for taking time to join us. Now, on behalf of PETplanet, I would like to particularly mention and thank our sponsors of this event. Sipa are well known in the industry for the design, manufacture and supply of PET preforms and container production systems. StackTeck Designs manufactures and supplies preform and closure molding systems from its HQ in Ontario, Canada, to customers across the world. And now we have representatives of both Sipa and StackTeck here today who will be making presentations and who I will formally introduce later. Now, a housekeeping note, if you will, we welcome questions, so please feel free to pose them using the chat function during the presentation, but don't expect them to be answered immediately. We will deal with them at the end. And please restrict your use of the chat function to asking questions rather than saying hi to friends and colleagues. It would take us ages to scroll through all the hellos to get to the questions we actually want, so indulge us on this one, if you'd be so kind. Now, it's been quite an eventful few years, and the storms don't seem to be over yet. Just when we hoped COVID was behind us, along came the war in Europe. The supply chain across multiple sectors, from agriculture to chemicals, has been impacted. We have seen energy prices soar, although my latest heating bill shows a strong decline from the last one, so that's good news for me anyway. Now, the pressures in our industry include energy costs, but there are social pressures as well. Plastic and plastic bottles have almost become dirty words. Packaging is under attack from environmental lobbies all over the world. Now, a lot of their propaganda is baseless or exaggerated, but there is no denying that some of the images of blocked rivers, of beaches that have become rubbish dumps, and pollution generally are not fake. We have to face these issues and to remedy them. Now, we have a great lineup today to discuss these challenges, including Paolo De Nardi, who is Product Manager, Stretch-Blow Moulding at Sipa, and Rick Unterlander, General Manager, PET StackTeck Systems Ltd. But appropriately, given the scale of the challenge with recycling, we start with a presentation from Indorama Ventures Ltd. Indorama is the world's largest recycler of plastics, of PET especially. It has built its presence in North America very quickly and is expanding too with the construction of a new factory in Corpus Christi, Texas. Its innovations are surprising and some of them offer some great hope. Now, we're privileged to have with us Srinivasan Prabhushankar, known as Shankar, who is CEO of Recycling at Indorama Ventures Public Co Limited. Shankar is a chemical engineer by education and training. He was appointed to head Indorama's PET in North America in 2011 when it bought the PET assets of Invista in the USA and Mexico. In 2016, after further acquisitions and a relocation to Alabama, Shankar was appointed in 2020 to the position of CEO of Indorama's global PET recycling business. His mandate is to grow Indorama's PET recycling footprint from its current level of 550 kilotons, that's 550,000 tons, to reach 750 kilotons by 2025, and then to double it again to 1.5 megatons by 2030 through mechanical recycling. Shankar, welcome. We're delighted to have you with us today, and I'm pleased to hand over to you.
Thanks a lot, Ruari, for that. All right, once again, Ruari, thanks a lot for that nice introduction. Good day to all of you, and thanks to the organizers for including me in this webinar, the first one of 2023, to talk about both virgin PET and recycled PET from Indorama Ventures perspective. Before I talk about that, let me give you a very brief introduction to Indorama. So Indorama Ventures is a global chemical company making sustainable products for the society. So we have about 140 plus manufacturing sites in 35 different countries which is across 6 continents with more than 26,000 employees. And we are a PET-centric company with a global capacity of 6.2 million tons of PET per annum. And the scale of our capacity and our market share is shown in this image. On the left bottom, we have more than 20% market share globally. If you focus on the middle section, we talk more about our sustainability drives and the recognitions that we are getting globally. Organizations like Dow Jones Sustainability Index, EcoVadis, ChemScore, all these have recognized Indorama for our focus on sustainability, which includes the recycling of PET. So in 2019, Indorama pledged to Ellen MacArthur Foundation that IVL will recycle 750,000 tons of PET by 2025. And that is an equivalent of 50 billion bottles per year. Today, we recycle about 30 to 35 billion bottles in a year. This whole thing will take about $1.5 billion of investment. And we are very well on our way to reach this capacity. So now to talk a little bit more about PET and recycled PET capacities worldwide, you can see its disproportionately large presence in Asia with next presence in Europe and North America. So the installed capacities here, the numbers we are providing are installed capacities. So installed capacity of PET is approximately 35 million tons worldwide, and of which Asia is the largest with 23.3 million tons, followed by Europe at 4.9 million tons and North America at 4.6 million tons. The other regions do have some smaller capacities. The global utilization rate of PET plants, depending upon the year, the number of force majeures, or other constraints like logistics and things like that, the utilization rates are usually ranging from about 70% to about 80%. Now, you can also see the installation of recycle capacities worldwide with about 20 million tons of installed capacity. Again, there Asia leads with about 12.6 million tons capacity, followed by Europe at 3.3 million tons capacity and North America at 2.4 million tons capacity. But when you look at a recycling PET, the capacity utilization is not as good as that of virgin PET. It's lower, and mainly it is caused by the collection rates. The availability of raw material to these facilities are limited, and that is one major reason. Now, with having said that, now what exactly is Indorama doing in this recycling capacity? So I already mentioned to you all that we have this commitment to reach 750,000 tons by 2025 and then double it to 1.5 million tons by 2030. So, even during the pandemic, in last 4 years, we have added 9 additional sites globally. All the sites that have been marked with green are all new sites that we have either built or expanded or acquired. So all this are what we are doing in the mechanical recycling space. Now, in the mechanical recycling space, what have we done on the technology front? So we have developed our own in-house technology for washing the bottles. So we do deploy state-of-the-art robotics in our plants, and especially we do that in regions where it is very difficult to hire people. Now, our focus is more towards circular economy. So we are installing rPET lines or pelletizing lines, and we are using almost all of the latest generation systems, which can provide the best possible quality, consistency, and the best level of decontamination. Now, to complement this mechanical recycling, we are also engaged in the commercialization of novel chemical recycling technologies. Indorama Ventures, we don't do basic research on chemical recycle ourselves, but we do work with technology providers. And one of them, from European perspective, many of you might have seen that we have signed up a venture with Carbios to set up a chemical recycle plant in France. So like this, we do work on the chemical recycle side also. At the end of the day, our idea is to ensure that no part of the PET package ends up in landfill. Now, why PET? I think I'm preaching to the choir, but still, I will go ahead and let you all know that PET is the most versatile polymer out there. Whether you are using it in a packaging need, in textiles, in industrial, automotive, or hygiene markets, in every industry, PET has the best presence. We all know its attributes like it lightweight, transparency, clarity. But on top of all that, it is the most recycled polymer by a big margin when compared to any other type of polymer like polyethylene or polypropylene or polystyrene. And then virgin PET comes with the least carbon footprint, and that carbon footprint goes a lot down further when you recycle it. It also competes with quite a lot of other packaging substrates like aluminum, glass, and paper. So I have given a very small snippet of the LCA comparison, but there is a very recent LCA study that was released by NAPCO, an industry association for PET in North America, and you can refer to that. It's more recent study. And so conversion from other polymers and from other substrates to PET continues to happen. So that is why you will see that the virgin PET capacity utilization and consumption is growing year after year. Even in bad years, you still have growth in the consumption. And it is growing above or faster than the GDP growth. So now, having talked all these good things about PET, don't you think there are any challenges to the industry? Oh, yeah, there are quite a lot. Like Ruari mentioned, there are quite a lot of negative publicity against plastics. So PET is put in the same basket as plastics, and we do get attacked. But is that's a distraction which the trade association and the industry takes care of answering based on the merit. But our biggest challenge from my vantage point, because I'm taking care of mechanical recycling for Indorama Ventures, so is the availability of our feedstock. That's one of our biggest challenges. So why does that happen? There are three major reasons. One is infrastructure, second is consumer behavior, and third is regulations. So on the infrastructure side, companies like us are investing in building recycling capacities worldwide. The machinery and the technology suppliers are also constantly innovating and trying to provide us solutions which takes care of deteriorating feedstock quality. But I can't say the exact same thing about the collection infrastructure. So collection infrastructure in some regions are outdated. In some regions, we don't have the right type of sorting centers with optical sorters to provide us a feedstock of the best quality possible. Over the years, we constantly see the quality of the feedstock we get is deteriorating. So, but that's not all bad news. I can give you some examples, like, for example, in the US, the waste management companies have very recently announced big investments in retrofitting some of their metal recovery facilities. And that is very good news, and it is very welcome news also. Now, on the consumer behavior side, so on the consumer behavior side, the most important aspect that Indorama is focusing on is to educate the consumers. And we think educating people when they are very young is the best way to do it. So we have started, and I think we made a public announcement about it in a day or two ago, wasteheroes.com. This is a website where you can freely download educational material, which is levels from kindergarten all the way through high school. And it's done in multiple levels like advanced, medium, all that. And on top of that, it comes in multiple languages and it comes with instructions for the teachers how to do it. One very important point to note here is this is neither PET centric nor talks about IVL. This is about handling waste and to educate consumer, especially younger consumers, on the importance of how to handle waste. So, that's one thing on the consumer behavior we do. And then on the regulation front, if you see, many countries are doing the right thing by having deposit return schemes or extended producer responsibility and other collection schemes. Quite a lot of other countries are following. They have announced implementations, but many of them implementations are either slow or not in the right direction. But those things have to improve to make that's a big challenge that we need to address. And one other thing from the regulation point of view, you can see is not all countries allow recycled PET to be in contact with food. So, but quite some countries are thinking about this and changing their mind, like Thailand and India. So we expect quite a lot of other countries which do not do that to follow suit. So overall, I conclude that PET, along with its recycled PET, has a very bright and sustainable future, provided the industry, the governments, and the public do play their part. Thanks a lot. Appreciate your presence, and thanks again to the organizers.
Thanks, Shankar. Thank you very much indeed. That's even better than I expected. It's more than just food for thought. That's a banquet. We look forward to following what's happening with IVL in the years to come. And indeed, probably later on this year, we'll see such expansion. That's great. So next up, we have Paolo De Nardi. Now, Paolo graduated from the University of Padua in 2003 with a degree in materials engineering, and he joined Sipa the same year. He is experienced in R&D, product development, and sales and marketing, so he's quite an all-rounder. Now, he now holds the position of Product Manager Stretch-Blow Moulding at Sipa, and his duties include managing new developments on both linear and stretch-blow moulding machines. And he's going to speak to us today about new investment markets and new trends in PET bottle design and production. Paolo, the floor is yours.
Thank you, Ruari. Let me get the control of your next 10, 12 minutes. Sorry for that. I'll try to make something nice for you and to have some thoughts to be shared within this interesting collection of people. Is very passionate about this PET. As we all know, PET is really receiving and giving passion to the people that are working on. Thank you, Shankar, for your presentation. That is very given the right pace for my contribution. That is about market and trends. As Sipa is seeing the PET bottle production, so using the resin, the PET that we all know that are so precious and important 20 years ago, today, and in the next 20 years at least. And we want to share some of the views that we see in this market. The view is that Sipa is acting in this market, in this scenario, with our unique attitude to be a player that is covering 360 degrees all the steps of the PET under one single roof. So starting from the rough idea, the prototypation, the tooling, the system for preform, for bottle, for filling, for downstream equipment, and then the complete line management. That gives us quite a perspective on the market view, and we can share with you three of the main trends that we see from this market, where we see an interesting increase of demands for large size container, large, I would say above 5 liter. Some alternative solution for the conversion of glass. As Shankar was saying, there are a number of conversion ongoing from other plastic to PET, but also from other material to PET. Glass is one of the most recent and most interesting example, as well with a continuous trend for the more sustainable developments in a circular economy approach with different declination of the sustainability. And for us, it means development and support of solution and systems for the large size container to couple with this higher demand of large size. Together with some more packaging conversion, I will share some example of these. And the continuous trend for a more sustainable packaging, starting from the design and with all the features that create a good packaging. What does it create a good packaging? Packaging is protection, is a great way to protect the food or the liquid to use PET. PET is always a very good solution to give protection, but in these three trends, we see some additional protection performance to protect the content, the precious content inside of the bottle. And we will see on the large size where we're going to protect with a stackable container for sturdy logistic, a very solid container to protect and transport precious liquid, as well as to protect people, thinking about getting rid of the brittle and fragile glass to have a solid and safer container. And protect the environment, of course, to have a solution that is not only performing well, but is performing well in a multiple scale. So considering the world where we are living, the scenario that we need to comply with, so to be able to have a sustainable, recyclable possible, and in general, a circular packaging approach. So let's start from large size container. Large size is growing. We see trends pretty clear where the big bottle, above 5 liter, are growing. In the mineral water market are growing a lot. It's an important growth, more than 5%, specifically on the more than 5 liter size. So the market is ready to grow in the next 4 or 5 years. Edible oil as well as an important, relevant growth in the range above 5 liter. And also here, it's important to consider these and to adapt the solutions to these market trends for the next 5 years. So we work to develop a new, more solid logistic on a 20-liter stackable container that will be presented to the Interpack in Düsseldorf in 1 month. This is the concept to give more protection of the liquid, the important liquid, to have a safe transportation, simple logistic management to reach even the most remote places throughout the world, not just when tap water is easy or supermarket is close by houses, but to solve the logistic limitation worldwide. We take care about this because we believe that we can give a contribution to this trend thanks to our full packaging approach. So to consider all the steps to get to this interesting solid solution that is starting from the neck, preform design, the closure, the handle, the bottle, of course, and all the complete line solution as well with robotic handling and the proper palletizing of this solid container. From a technical point of view, we can say that pretty light, it's a 500 gram, more or less half of the current alternative in HDPE or metal, so to convey the same 20-liter liquid. So that it's a ratio between a liquid and plastic to transport it that is really favorable. It is a solid design, not just for the automatic, precise line automation, but also for the real life of this container that are mainly transported and managed on a severe manual handling. So the need for a solid design in all the direction to have a very high vertical top load to sustain the real condition. This can be produced on different technology, for example, our injection X-form and the linear machine SFL, as well enjoying our ROBI, the robotic palletization systems. We are talking about conversion, so glass is under attack. Of course, we know that glass price is increased a lot in the last 3-4 years, and it's still maybe not close to the end, this growth. And we see that market, like a wine, is concerned about the cost of a glass. There is a shortage in France. Today, as well, in these days, we have in Italy, in Verona, leading fair for a winery, where there is, again, an important topic with the cost of the raw material that is impacting the final price of the bottle. But also on the cosmetic and luxury, we see that big brands like LVMH is pushing to have more sustainable packaging and packaging in PET to go after the need for the market to be more conscious about the real impact of the material choice of the packaging in our daily consumer products. So we work and we are introducing this sparkling wine bottle that is the first sparkling wine in the world, where we convert from glass to PET, the classic 750 ml sparkling wine, to transport the safe liquid. And okay, I'm talking from North Italy, where the production of wine and the value of sparkling wine is really important. So we know that it's important liquid. We can protect it for up to 24 months with a completely unbreakable solution, very solid, very simple, very nice to handle in the hand. And we take care about, again, the full packaging development, starting from the cork neck. So the existing typical cork from cork neck and metal cage, to develop a special neck in PET to mimic the classic glass one. The special, very special and patented the preform design and the bottle design with a very heavy solid base in order to maintain the shape even with a high pressurization. And we are saying this all within our solution in terms of design and industrialization that are being patented. At the end, it's a solution for have a PET bottle with a lower cost than glass, of course, with a simple logistic, much more simple to manage a PET bottle, or just even to have a just-in-time in-house production of PET bottle. And environment-friendly, because as Shankar was saying, also NAPCOR was confirming the impact of PET that is using much less greenhouse gases than glass or aluminum. And the consumer experience, despite the fact to accept the conversion from glass to plastic, many enthusiastic people about wine may not like it, but the market is much wider than the few that are paying 50 euros per bottle. And the market is ready to accept this very light and very smart solution to have a sparkling wine in PET as well. It is suitable for glass filler, so the top load is very high, the compatibility with current design is complete. So it's very simple also from an operational point of view to switch from a glass on the high end to PET on a medium and low end product. This is produced again on our injection and linear machine or rotary machine and other cartoning and packing machine. Another interesting conversion to share with you is a perfume bottle we presented in Cosmopack a few weeks ago in Bologna. Is the need to give more protection with an unbreakable solution for the cosmetic, with an easy and safe logistic, without the need to consider the risk to scratch, to damage, to break a very important and expensive container, having all the flexibility of a PET in terms of color, shape, change. Full design options are available, are open. Of course, we apply again the neck and the specific preform design to have a very fast prototyping to give to the market this container, but it's an option for any kind of new solution, new geometry, new sizes in this perfume market. The consumer experience is very good because the container is a solid like rock, even if using a much lighter amount of material than a glass, and of course using less greenhouse gases, with a simple production, just one machine to have the solution close to the brand owner factory. I was speaking about lightweighting, think about 80% less. So it's an important saving, of course, with all the contribution to the lower cost, talking about energy, talking about raw material, talking about logistic, and at the end, the benefit for the environment. This is produced on a single step machine, the ECS-SP, for super special container, but as well can be adopted on other more high volume platforms. Let me conclude. I think I have still a couple of minutes with sustainability and sustainable choice to make the right packaging. We use three main concepts, 3R: reduce, reuse, and recycle. We take care about it, reducing the weight, turning to refillable or reusable container whenever it's possible, and to, of course, push for recycling. Recycling actually the flakes, so turning from flakes to fresh bottle, or to design from the beginning the bottle to be compliant with the design for recycling concept. We call our PET is the concept to have all features in our hand since the beginning, since when we start with the first scratch idea, to guide the people to go to a sustainable solution in the design, in the choice of materials, colors, and so on. Here is a quick example. Of course, the use of our PET is everywhere. All the big brands are pushing like hell to have much higher 101% of recycled PET in their bottle. And it's clearly available, the solution. So to get rid of virgin fossil fuel, to drop in CO2, because of course, as soon as we use recycled PET, we have a lower impact, lower production of CO2 for each gram of plastic. And we take care about, with all the developments, in all the development steps with our design approach, starting from the neck, the preform, the label choice, the glue selection, the color of the resin, the additives, and so on, in order to have less plastic, less emission, less impact. From a technical point of view, using our systems, we can contribute to have a better or more flexible heating system in order to adapt to various quality resin that are coming from the recycling. That may be one of the variables that are being introduced, or quality controls to monitor the performance and the real output of the bottle production. Again, from a technical point of view, we already been here since 10 years. So the possibility to run 100% rPET is not a technical question. It's not a marketing question, because of course also the consumer are today very ready to buy a bottle even if it's gray or yellowish. The consumer expectation is pretty high. There is an operational point or issue that the 100% recycled PET is not sustainable today because of the collection and the separation rate in the best country in the world. Globally, of course, it's even a more complex topic. So to get the available collection capability to feed this brand owner desire to have 100% rPET. So again, from a technical point of view, we are ready. It's a matter to find the operational correct range to make it sustainable through the whole life of the PET. This is best fit with injection and high-speed rotary system, but as well also with our Extreme Renew in order to have the direct conversion from flakes to preform and bottle and fill in one system. I conclude with label-less. There is another trend, important trend, in order to have less fossil fuel, or better, no fossil fuel using 100% rPET, remove even additional plastic like the label, and embed the label feature on the packaging. So it's a new way to design, considering this option to have less plastic, to have a shelf differentiation. Of course, I'm removing the nice color and pictograms and graphics on the label, but I move to a more transparent container, embedding the label topic on the design. This is, of course, opening a new option and new constraint on the design itself. Introducing also some opportunity to have a special mold manufacturing. Blowing pressure must be accurate in order to apply this negative or positive impression to the logo and to all the marks to be solid and readable by the people. This can be in linear system, rotary system, or even on blow mold for existing assets. To make a long story short, it's a key from our point of view to manage all these 5 trends, 5 examples that we shared, to manage the full process know-how. So starting from a raw material know-how and selection, of course, considering rPET as the best option, apply all the best design expertise in all the steps of the development to get the final consumer product. Get a little bit of flexibility, why not Italian flexibility, to design and invent and solution on a plastic and on the systems and new solution development. Add a touch of design for recycling feature down to the end of the line, so from pellet to pallet, in order to manage all these topics in all the steps down to the warehouse filling, or even down to the last consumer to use this bottle. Thank you a lot for your attendance. Here we are.
Thanks, Paolo. That was great. It was quite a fascinating presentation. I will ask you later about the sparkling wine container. That's a subject that's very close to my own heart. But we'll talk about that later when we have the questions. And anybody, just a reminder, anybody who does want to ask questions, feel free to put them in the chat while the presentation is going on. We will deal with them at the end of the 3 presentations. And the third of our speakers is from what nearly became my home country and my own backyard, which is Ontario in Canada. StackTeck, which is based near Toronto, specializes in the design, manufacture and supply of preform and closure molding systems. Now, Rick Unterlander, who is General Manager PET with StackTeck Systems Ltd, is quite a veteran in the industry, having been introduced to PET preform molding in 1984, when I imagine our hair was longer, Rick, and our backs were probably a bit more supple.
Thanks for noticing.
That gives him nearly 40 years of PET preform molding experience. And he's been involved in preform mold design, R&D, engineering, manufacturing, sales, business development, as well as preform machine development and validation, process optimization, and training. And he also holds numerous patents for injection and stretch-blow moulding of PET preforms. I think we can safely say there's nothing about PET preforms that you don't know, Rick. Now, he's just the man to talk about advances for PET preform moulding, including technological solutions, developments, and future prospects. Rick, the floor is yours.
Wow. Well, thank you, Rory, for that nice introduction. Thank you, Shankar and Paolo, for your very interesting talks. Hello, everybody. Thank you for joining us today. As Rory mentioned, I've spent 39 years in the preform molding industry. 9 years, the last 9 years at StackTeck, representing our PET preform mold business. And if I look back at my earlier days of running a preform molding shop, I recall waking up every morning wondering, first of all, is everything still running? And secondly, was the preform quality maintained throughout the night? This was my concern day in, day out. And on that note, today I will be discussing a technology that helps to address this concern by means of improving the molded preform quality consistently. And as an added benefit, it even helps to achieve faster cycle times. So please allow me to introduce our ISO technology. So the name ISO refers to isometric, describing a three-dimensional representation of an object. It is this isometric imagery that our engineers use to configure a network of distribution channels for optimizing flow characteristics. The illustrations on the screen show a mold water channel on the left and a hot runner melt channel on the right. Both of these are representations that show the freedom of design that can be realized using ISO technology, and how this can be used to elevate mold and hot runner performance for better product quality. I'll go into a little bit more detail about this. So ISO technology makes use of a state-of-the-art diffusion bonding process. Diffusion bonding can be defined as a solid-state diffusion process where the atoms of separate surfaces intersperse to become one. This results in the formation of a single, inseparable object, such as the three manifold plates shown on the screen. To prepare for diffusion bonding, the melt channels are machined directly on the surfaces of the adjoining steel plates, then polished and accurately mated together. A notable characteristic of diffusion bonding is that it doesn't use any form of brazing, soldering, or welding. There's no paste, no flux, or bonding elements used at all. The adjoining plates are simply in direct contact with each other during the entire process. So the next phase involves applying a high pressure and heat to the plates, just below their yield point. This is maintained for a period of time around 15 to 20 hours, depending upon the plate sizes used. So during this time, a molecular exchange takes place across the plates. And just as gases and liquids diffuse, solids do as well under the right conditions. And once the process is completed, the result is the creation of a single-piece manifold. It's robust, it's accurate, and it has no risk of separation. So why do we do this? Well, I'll show you a comparison that highlights this technology. Traditionally, manifolds are manufactured using gun-drilled linear channels that interconnect within a steel block, kind of shown on the left. You can see here in the red channel lines here that these lines are drilled from the side and then plugged. Here's another one that's drilled from the back and plugged, another one here that's drilled from the back and plugged, and then they interconnect to form a melt channel to each drop. Now, when diffusion bonding is employed, as shown on the right, it allows the entire channel arrangement to be simplified without the complications of using end plugs, so there's no risk of leaks. The melt channels can be contoured and shaped to provide an optimized flow path to each cavity. So here's a look at a 96 cavity ISO hot runner layout as manufactured by diffusion bonding. It permits smooth, level transitions, eliminates any sharp corners and edges, and there are no dead spots at any channel transitions, turns, or splits, and this helps to enhance flow characteristics and minimize pressure drop throughout the entire channel layout. It's a characteristic that benefits PET and other heat-sensitive materials. So how does this impact performance and part quality? Well, here I'm showing a back-to-back comparison of a short shot test done with a conventional hot runner and our ISO hot runner. It's from a 96 cavity, 28 gram preform mold. And in this test, we stopped the injection when the preforms were filled to 50%. The resulting fill pattern shows the weight distribution of the plastic injected into each cavity. And this helps to highlight imbalances in a hot runner. In this example, the weight variation was reduced from 46% to 19%, and that's the percent relative range, which is the maximum range of all the parts divided by the average weight. The improved uniformity with ISO translates into a larger processing window for molding, minimizing the need to adjust and tweak parameters for the outlier preforms, those ones that may be on the edge of acceptable quality. This makes setting up the process conditions easier and quicker, such as when speeding up cycle times or when starting up a new mold. There's less need to make adjustments to fix quality problems on the outlier preforms. And as a downstream benefit, the customer in this example reported less bottle-to-bottle quality variations at the blow molder. Now here's another back-to-back comparison showing a reduction in pressure drop using the ISO hot runner in the same 96 cavity 28 gram preform mold. Two injection rates were set up with the conventional hot runner at 10 and 13 grams per second per cavity, resulting in a 680 and 780 bar peak injection pressure respectively. With our ISO hot runner, we were able to achieve a 16.9 gram per second per cavity injection rate, yet still achieve a slightly lower peak pressure than the slowest injection rate using the conventional hot runner. The preforms made in each case were checked under a polarized light to confirm that no changes in stress pattern were visible. The end result was a significant injection time reduction, which reduced the overall cycle time. So these two characteristics, the improved balance and the reduced pressure drop, enable technologies such as overmolding and thin wall preforms to be accurately and consistently molded. Overmolded preforms tend to have very thin layers with high L/T ratios, and this requires both a tight cavity-to-cavity shot balance and a low pressure drop throughout the hot runner to ensure the layers are accurately and consistently formed with no risk of short shooting the very thin layers. This also benefits monolayer preforms, most notably with flat water applications, especially as they become thinner and thinner due to lightweighting programs. Another example is shown here, comparing a 144 cavity application with a conventional hot runner and an ISO hot runner. The comparison shows improvements realized in three major categories. The peak injection pressure was reduced by 19%. The preform weight variation was cut in half, and the average acetaldehyde level was reduced by 24%. Now for the acetaldehyde, this customer uses an AA scavenger to minimize AA generation. This was an important factor as it enabled using a lower amount of AA scavenger with the ISO hot runner, which directly impacted the cost. And for color applications, the ISO design can help with scrap reduction. Here I'm showing some pictures of a color change from green to clear using a 72 cavity, 15.3 gram preform mold. With ISO, no visible color, spots, or streaks appeared after 30 cycles, and the preforms were approved for collection. Now, this was a significant improvement compared to the conventional hot runner, where they typically scrapped about 220 cycles worth of preforms. The smooth melt stream achieved with the ISO design facilitates the free flow of material without hangups, a characteristic that benefits melt flow of heat-sensitive materials like PET, even without using color. So where else can we use this technology? Well, I'd like to introduce now CoolTrack. It is another way we take advantage of our diffusion bonding technology, and it also helps to improve product quality and cycle time, but now on the cold half side. So CoolTrack is best described, or more simply described, as conformal cooling. Similar to how ISO diffusion bonding changes the way hot runners are designed and manufactured, the same three-dimensional design creativity can be applied to cold halves. The ability to direct water to areas that are difficult to cool can make a significant impact on both part quality and cycle time. CoolTrack has been successfully used on a variety of PET and also non-PET applications. Now here I'm showing a comparison of neck rings with a PCO 1881 thread finish, conventionally drilled on the left side, and CoolTrack on the right side. Drilled conventional designs often limit cooling effectiveness due to the difficulty in positioning the water channels in certain areas. If you can see my cursor, you can see here where the inlet and the outlet are for this drilled channel over here, and the water kind of goes up this path, short circuits here, and goes down this path. And these sidelines are drillings, but they're plugged in order to connect the stream over here. But when CoolTrack is used, there's one inlet, and it's a complete wrap around the thread area here, and one outlet. There's no plugs being used and no drill lines at all. Here you can see a plan view of it, and some back-end views and rotational view here. So CoolTrack designs are able to target and conform to those hard-to-reach areas. In the case of this PCO 1881 neck finish, CoolTrack delivers over 300% increase in cooled thread boundary, as well as coverage of the B1 diameter. And you can see here, if I rotate this view here, the B1 diameter is just above here, just above this cooling line and the pilfer band. But on this side where CoolTrack is applied, you can see there's full coverage of the bottom threads and the B1 and the pilfer proof. Here's the back end view here, you can see, compared to the back end view of just the drill channel. So how does it perform in real life? Well, in the example shown here, we were challenged to improve upon an existing preform molding application. It was an 18.58 gram preform with a PCO 1881 thread finish running at 7.5 seconds. The cycle time limitation was the thread temperature of 64 degrees C. With the StackTeck mold using CoolTrack, we were able to target the critical dimensions of the PCO 1881 neck finish, especially the B1 thread dimension, which has a wall thickness just over 2 millimeters, and the pilfer-proof band, which has a wall thickness of just over 3 millimeters. And these thread dimensions are considered relatively thick when compared to the 2.6 millimeter body wall thickness of this preform. So CoolTrack was able to reduce the preform thread temperature by 14 Celsius. And interestingly, that was achieved at a cycle time that was about half a second faster than conventional. So in this case, both CoolTrack and the ISO hot runner technologies were key elements to this achievement. And with that, I conclude this talk about our ISO technology, how it is used, and how it contributes to improve part quality and even reduce cycle times. I leave you with a couple of images shown on the screen to show where it can be used. I hope the time was well spent for you, and I welcome any questions and emails if you'd like to discuss in more detail later. Well, thank you very much.
Rick, thanks very much indeed. That's very kind of you to share your knowledge and experience with us. Now, before I go to questions more generally, as you're there, or I did have you on the screen just, yes, I've got you back. Now, the joining process that you were talking about there, it reminds me of friction welding, which is a form of forging. Is it similar, or is it indeed friction welding?
It's not friction welding. It's they're just placed in contact with each other under a level load and high heat just below the yield point, but for quite a long time. And what happens is just by through contact and under those conditions, the molecules actually exchange surfaces, right, and they go from one to the other, but there's no friction involved. But it is held there for quite some time to do that. So it's a really robust process. And eventually, like 2 pieces or 3 pieces, 4 pieces, whatever amount of plates you have, become one, like truly become one piece.
Right. Like
no bonding marriage. Elements. No, yeah.
Yeah, okay. And the other thing is, why have you chosen that particular technique rather than, for example, additive manufacturing, which is the coming thing, if you like?
Yeah, additive manufacturing hasn't achieved, the quality we get out of polished stainless for manifold design yet. So it's still in its infancy. It's something we're looking at for possible future considerations. But right now, the diffusion bonding process is so highly developed, and especially for something like where a manifold geometry can take, it'll take great effect on it. So.
Okay, thank you very much indeed. I'm just going to check to see. Right. if any other questions come back, I'll let you know. But that's the two that we had for you. Now we've got another few questions flooded in. I will go to Paolo first. Paolo, now, as I said, sparkling wine is a subject close to my heart. My wife prefers Prosecco. I like Cava and Champagne. But the container is that more challenging, or is it the same challenge as coping as designing packages for CSD, for carbonated soft drinks?
Yeah, it is more challenging, definitely. The carbonated wood wine is requiring a lot of performance, considering the liquid that we both like and enjoy. So the need to preserve from light, from oxygen, from CO2 is more demanding than the one of the standard CSD. And as well, the carbonated wine is challenging from a container point of view compared to a red or white wine that is typically produced, packed also in PET since many years. So the new evolution is the possibility to as well pressurize the wine.
Okay. Well, of course, with wine, there's one thing you don't need to worry about, and that's a long shelf life, because it tends to get drunk fairly quickly. Sparkling wine, anyway, I think. Right. On the perfume container, I think you said something about it being lighter, the material, but did you say that it uses actually more material than glass?
No, maybe I misspoke. It's using less material, so it's using a plastic that is around 20 gram for a small 30 ml for perfume container, compared to 100 gram on a glass. So the ratio is definitely in favor of PET. Okay,
and the 20-liter stackable bottle. Now that has advantages of that you've pointed out, but how heavy does the container have to be in order to support the weight of full containers above them? I noticed that the illustration showed them only stacked 3 high rather than 5 high or whatever. But is what you're gaining in terms of convenience of transport and logistics being wiped out a little bit by the weight of the container that can actually bear the weight above it?
Well, actually, the performance of the container is very safely, and I'm thinking around 4, 5 or 6 as a safety factor, considering a 4-layer palletization. So the container is sturdy enough to manage 4 layers. However, from our experience in the global average scenario, having a 4 layers, it's difficult to be transported by trucks because it easily come over the limit of truck transportation by the weight, because the liquid is so compacted that is having basically half truck with this pallet 4-layer, and the half of the truck is empty due to weight limitation on the truck. So if you are transporting also glass bubbles or soft material, you can manage the transportation. However, it's more common and typical to consider a 3-layer palletization. The bottle itself is easily 4 layers.
All right. Okay. Thank you. That's great. Shankar, I've got a question here. How do you see the developments for feedstock in case the chemical recycling will expand further? And what do you think about bio recycling for PET?
Okay, you had 2 different parts to that question. Number 1 is the feedstock for the chemical recycle. So we have things like colored or opaque PET bottles and packages, which usually get downcycled. So instead, if that goes into chemical recycle, so you get them back colorless, clear, and ready to be used again. And we also have fractions that come out of mechanical recycling in the form of fines and small bits and things like that. So that can also be used in chemical recycle. On top of that, there are non-packaging type PETs available in the form of carpet fibers, X-ray films, things of that nature that can go into chemical recycle. So chemical recycle as a space will have enough amount of feedstock, mainly, as I said, Indorama and the whole chemical recycling teams vision is to ensure that no part of the PET package ends up in landfill. So every single bit is able to be recycled. So that's the aim. Now, talking about bio, yeah, if you are talking about the enzymatic, yes, we are evaluating that technology, and we have signed a JV, and we will be, soon taking the investment decision on putting up a plant in one of Indorama's facilities in France. So we think the technology is well developed and ready for commercialization.
Okay. Now, this is from me. I read, or actually I think I edited a press release report. I was trying to find it on my computer, but wasn't able to, about IVL recovering post-consumer PET from a landfill site in Mexico. Am I misremembering, or have you actually been doing that?
No, we don't do that. And we don't get into the collection space to begin with.
Okay.
We buy from suppliers, mainly recognized suppliers, and they go through a supplier qualification program for us, where we ensure that they don't use child labor or, forced labor or, things of that nature. And so, we go through a very strict supplier qualification process. So that was a misrepresentation. And I personally don't remember that, but anyway, I'll check it out.
Yeah, it's okay. I mean, it may have been that you come up with a chemical, or I may have misremembered, or it may have been that you come up with a chemical process that enables you to take stuff from pretty dirty stuff and get it back to food quality.
That is possible, yes.
Right, okay. Yeah, and anyway, if you're going to dig up landfill in northern Mexico, that's asking for trouble, isn't it? Asking for a different type of contaminant anyway. All right, okay, we're now actually at the end of our time, so I'm going to call a halt to the proceedings. I'm going to thank all three of our presenters, Shankar, Paolo, and Rick. Thanks for your time. It's been a very interesting seminar from my point of view. I've learned a lot. I usually do, but I've learned possibly even more than usual. And thanks to everybody who came along and attended. There will be a recording available on the PETplanet website, which is petpla.net, in due course. Thanks for everybody. Thanks for your attention. Thanks for your attendance. Bye-bye now.
Thank you, team.